Hi, I'm Wally from Black Dot Energy, and today in our documentary series, we're visiting a residential application of solar as an energy solution. At this site, we've got both solar thermal, in other words, solar hot water, and solar PV for power generation that's been done at this domestic residence. I'm here with Henning Holm from Holmes and Friends, which was involved with the primary design, and then Etienne from EVB Electrical, which did the installation. He's also the owner of this solar plant. Henning is going to tell us a bit more on the design side, and then Etienne is going to give us a bit of a rundown on the installation of how the system was done. Henning, can you give us some more information on the installation?
There we go. So we had the opportunity here, as you've heard, that the installer and the owner is the same person, which is a great opportunity to see and test different systems. Very important was to understand what the needs are and to prioritize the energy usage. So as this is Marble Hall in the Limpopo province, it's very hot in summer, not so cold in winter. It's really good climate. We had a look at the insulation. We had a look at the air conditioning with a VRV air conditioning system, which works fantastic. But then there's a look at the insulation. We had a look at the air conditioning with a VRV air conditioning system, which works fantastic. But then there's a component hot water, which typically is a very large component of electricity consumption in a household. 30 to 40% is not unheard of. And in this particular case, we centralized the hot water system, started with a small system, and it can be enlarged as the need arises. But this makes it possible to transfer heat from the guest room, for instance, which normally is not in use, to other rooms and or the kitchen. Once that was done, we looked at the electricity bill, what is left over, and installed a small hybrid system. This is just above the 5 kilowatt system with a little bit of battery backup for the eventual load shedding or failure of electricity grid. It would sustain those lights and a few essential services like the security system or the entertainment system. Having put the system up, Etienne, who's a local electrician, has put up larger systems, and this is really to demonstrate also that he practices what he preaches, which is always a good principle. Etienne, my first question to you is just from a practical perspective, how long did it take to put up the system?
Thank you, Henning. The system is actually was very quick to install. It took us approximately 2 days to install wiring, panels, inverter, and so forth. So it was very quick installation. The type of brackets that we use is a very easy, accessible, and easy using bracket. So everything went quite quick. Like I say, within 2 days we installed the whole system, wired, and everything complete.
The calculation or the discussion with the municipality to connect a system, because this is a hybrid system, it in fact produces energy, and the excess energy which doesn't go to the battery or your own consumption goes back to the grid. That whole discussion, was this problematic? Was this a difficult thing?
No, it was actually not problematic at all. The head of electricity in Marble Hall and we know each other. So for me, what we did is he created a pilot site, which we use this site, and he installed a meter, which they call 4-quadrant meter, that's able to measure what we put back in and what we use. So what happens is at the end of the month, it has a modem in, and it automatically sends the usage or the surplus to their offices, and they send a bill accordingly.
Talking about which, what is your experience in terms of savings?
Well, for the first month, we had a very good saving. We're waiting on the next account now. The first month, we almost created all my monthly consumption we had created ourselves. So I had a very, very small consumption account. You still have your normal basic electricity and so on from the municipality, which is fine. So yeah, I can't complain about, well, not complain, I can be very happy about that. I am very happy about that, yeah.
Well, super, and there's a good example of how one would work in terms of efficiency, get the electricity lower and know where your consumption is, and then supply some electricity and integrate it, and it makes sense all round. The municipalities still get their basic fee for the services they deliver. We don't have such a big or large environmental print because the batteries are relatively small, and you can optimize and build the system modular as you go, and it seems to be a happy installer and client in one go. There we go.
Well, Etienne, hats off. I think we need pioneers like that to demonstrate these pilot projects and sort of illustrate to business, to municipalities, to homeowners how it can be done, how it can be integrated. I'm going to get Henning to take us through the inverter and the battery installation to give us a bit more practical side and on the technical side, how the hybrid system is incorporated with the backup. Henning, can we take a walk there to the inverters quickly?
Let's have a quick look. So here we are in front of the heart of the system. What you see here is the orange switch box. That is the connection between the municipal and the local system. It's very important to get that right because it's all about security and safety. And that switch box needs to be according to law. There's strict regulations in terms of how embedded generators, which this one is, should be connected. Next to it, you see a 5 kilowatt hybrid inverter. This inverter converts the DC power from the panels into AC, which is then sent to the consumption of the lights and, in this case, TV and communication, as well as the alarm systems, and or to the batteries, and or, if there's additional energy available, to the local grid. Should the client consume more energy, specifically now night times, than generated, electricity will be fed from the local grid via the system or parallel to the system into the home, looking always that these batteries are fully loaded. The storage that you see is very small and is only enough to carry through for those 3-4 hours of load shedding or failure in the system. So you can have the essential services working, in this particular case, lights, alarm, TV, and communication. What you can see here is that the batteries are installed at a high level. This is so that the space in the garage is kept open as it used to be. There's ample ventilation space to the inverter, which is important to have it function properly. And you can see a very decent, well thought through installation, and all the conduiting and so forth done properly according to legislation and marked accordingly. A system like this would then not only save your electricity and have the related savings on environment, but it would give you some security should there be no power. And you can see it's a very simple, small system, relatively easy to install.